Welcome everybody to my talk. Today I'm going to talk about the very interesting topic about building IoT applications with Machina.io and Tinkerforge. So in the previous talk you already heard about some of the fundamentals of how typical IoT applications are built. Everything connecting from the sensors to the cloud and enterprise systems. In my talk I'm going to talk mostly about the device and sensor side and how to get the data into the cloud or enterprise side. I'm not going to talk about any enterprise stuff. Maybe first a few words about myself. I can consider myself a pretty hardcore C++ developer. I've been doing that stuff for over 20 years now. I also happen to like JavaScript, Java not so much. But yeah, any C++ developers in the audience today? Oh, well, good choice. Well, about 10 years ago, I started with in the meantime, pretty popular open source project called the Bogo C++ libraries. And the idea was something to build something like the .NET framework or the Java class library and all the nice stuff that you can find in other languages for C++. Have been quite successful with this. We're pretty well known now in the worldwide C++ community. And I guess the Bogo C++ libraries is actually one of the most successful Austrian open source projects on an international scale. And if you haven't heard about it, you should definitely check it out. I've also founded my own company. I have been doing Internet of Things kind of stuff for many years now, even before everyone was talking about it. Started with playing around with embedded Linux systems in 2005 or so. I also do some iOS programming. I'm a big fan of sailing and wrote an iPhone app for sailors. That's also quite nice. And what I'm going to talk about today is my latest open source project, which is called Machina.io, and which is basically an open source platform for building IoT gateway devices. This is actually a bit of the history where I'm coming from. So started with pretty hardcore C++ stuff. Back when I started with C++ in 1988, early 2000s, doing C++ stuff was pretty out. Everyone was doing Java and .NET, and as a C++ developer, you had to find your niche. So in 2005 or so, I started thinking, I like doing C++ stuff. What can I do with it? And I set my focus on all these kind of embedded devices that were growing ever more powerful. Embedded Linux was becoming popular. And started to build some C++ framework around that. Also did some early IoT projects a few years ago. And one of the things I noticed is you have all these nice devices, and every device has a web server built in. And then you take these devices, put maybe an UMTS or GPRS modem in, and put them somewhere in the wilderness to collect some sensor data or what else. And then you want to do some remote maintenance on the device. So the device basically has a web server on it, so you don't necessarily have to get into the car and drive up to the device that's maybe somewhere under a road bridge or whatever. But they probably know when the device is somewhere in a mobile network or in a ADSL network and so on. It's pretty hard to access the web server on the device. There is a firewall, there are net routers, and you just can't easily access this. And so I came up with a solution for that, which is mydevices.net. This was basically my first bigger step into the IoT ecosystem. And now a few years ago, I started tackling basically the device side. with Machina.io. And by the way, if you're interested in that kind of stuff, can talk to me later on. I have some pieces of paper that I can give to you if you want. So let's talk about one of the main issues of this talk today is Machina.io. Machina.io is a modular open source toolkit for building embedded IoT applications that connect sensors, devices, and cloud services. So what is meant by that? In a typical IoT application, you have some kind of interface to the physical world. So you may have sensors, like the canonical example in every IoT talk is you have the temperature sensor, and you want to get the data from the temperature sensor to the cloud. How do you do this? Theoretically, you could build a temperature sensor that has Wi-Fi, for example, built in and sends its data directly to some kind of cloud service. This may work, but it's probably not such a good way to build things in practice, because you first end up with a very huge number of devices that you have to manage. You have to configure every device for internet access, things like that. So what you usually do is you come up with a device that's called the IoT gateway. And the IoT gateway typically has, on the one side, some interfaces and connections to devices, sensors, sensor networks. And for that purpose, you use optimized protocols like COPE, ZigBee, or industrial protocols like Modbus or CANopen or whatever. You can also have, of course, USB or Bluetooth, or the old and still widely used RS-232 serial interface. On the other side, you have all these pretty cloud services from various kind of vendors. Things like AirVantage, Bluemix, Cumulosity, Sibley, whatever. And what all these cloud services have in common is basically they are big databases where you can send your sensor data to, and they store your sensor data, and you can build nice enterprise applications that take all that sensor data and do nice things with them, like generate some business value, as they call it. And for talking to these cloud services, you typically use protocols like HTTP, HTTPS, typically REST web services, and also MQTT. I think some of you may have been to the MQTT talk earlier today, so probably know about it. And finally, you have all these mobile or web clients. So take, for example, your home automation system. You might want to access your heating system or whatever when you're leaving the office to turn up the temperature or whatever. So you need some way to connect the app that's running on your smartphone to the home automation system in your home. And you want to do this, of course, in a secure way. And a lot of IoT systems are actually built in such a way that everything that's interesting happens somewhere in the cloud, which is pretty nice as long as your internet connection works and the cloud service works, and the Chinese government does not have a bad day and decides to launch a DDoS attack on your cloud service provider. As some of you may have heard about the recent attack a few weeks ago on GitHub, which was pretty nasty, as it had a pretty serious impact on GitHub, and it wasn't usable for some time. So the idea behind Machina.io is let's not do everything in the cloud, do some interesting stuff on the device as well. You know, our devices are getting ever more powerful. You now have the new Raspberry Pi 2, which has, I guess, a quad-core or whatever CPU with processing power that a few years ago were available only in high-end engineering workstations. And you now have this in a device that's the size of a credit card, basically. So, and everything for a price of about 30 euros. So it's basically a no-brainer just to take a Raspberry Pi or a similar device like a BeagleBone or whatever, and put some serious logic or even intelligence into it. So the idea is to collect some sensor data, talk to different kinds of devices, can also be actuators, of course. Have some local logic that does some interesting stuff, for example, control your home automation system or monitor some manufacturing process if you're on an industrial site. You can also, of course, use a local database like SQLite to store some data. You can have a built-in web server, so you can do directly on the device some nice web visualizations and stuff like that. And in order to do this, I've come up with this basically architecture for Machina.io. So on the lowest side, you have the Poker C++ libraries, which give you all the nice stuff that you need, like threads, file system access, built-in web server, XML and JSON processing, stuff like that. Then we have nice frameworks like remoting and OSP. Some of you probably know OSGI. Hands up. Yeah, quite a few. We have actually built something similar only for C++ and JavaScript applications. So show you in the demo later, it works quite nice. And then, and this is the interesting part, we have taken the V8 JavaScript engine from Google, which some of you may know from Node.js or from the Chrome browser, and integrated it with our framework. So in order to use all that nice stuff, you don't have to program in C++. You can nicely write JavaScript code. And then we have all the IoT-specific parts. We have generic interfaces to different kinds of sensors and devices, like temperature sensors, humidity sensors, GPS, GNSS, accelerometers, all the nice sensor types that you can find. Even serial ports if you need to talk to some legacy devices. We have built-in support for all the standard protocols in the IoT space, like MQTT. We have also planned to support COPE. It's not ready. We plan also to support some industrial protocols like Modbus and CANopen. Then we have interfaces to different kinds of cloud services, like for sending SMS messages, posting Twitter status updates, or talking to the cloud services we previously talked about for IoT applications. And then we have a pretty nice web user interface on top of it all, so you can easily manage your device. The whole is open source under the Apache license. You can find it on GitHub. It's built in C++, as I said, for best performance, and it uses a lot of major proven open source projects, like the Poker libraries, Google V8. For MQTT, we use the Eclipse Paho library. We use AngularJS and jQuery for web interface, OpenLayers for maps, the ACE text editor, and so on. Yeah, and it all is intended to work on devices like the Raspberry Pi, BeagleBone, and so on. What you also can do is, since the whole stuff also runs on a Mac or on a Linux desktop machine, you can easily build on your notebook and then easily deploy to a embedded device. These are some of the features we have built in, as I already talked about, the different kind of sensors, different kind of protocols, and different kind of broad services. It's also not just for hobbyists, but also for device manufacturers. So you can easily add APIs to your device. You can make your device programmable for your partners or end users. You can customize it as much as you want, and we have some security features built into it as well. The next thing I want to talk about is TinkerForge. Have some of you already heard about TinkerForge? Just a few. So basically, TinkerForge is open source hardware plus nice APIs. And it mostly consists of so-called bricks, bricks basically interface the whole stuff to your host system. So there's, for example, a master brick which connects via USB to your notebook. There is the red brick, which is a pretty nice embedded Linux system, actually. And I have different kinds of other bricks for all kinds of connectivity. And then you have the bricklets, which typically are sensors, IOs, switches, stuff like that. Then I have a few other nice stuff, like Ethernet interfaces, Wi-Fi, and so on. And also a pretty nice API. This is how the bricks and bricklets look like. So you can pretty nicely connect everything together using standard cables. And this is what a somewhat greater TinkerForge setup looks like. When connected via USB, this will definitely kill your cheap USB hub. And if you take Machina.io and TinkerForge together, you have a very fast way to prototype and actually develop and build IoT applications. So next thing I want to show you is a little live demo. So what you can see here in the background is the console from the Machina.io service. And after you log in to Machina.io, what you see is the web interface. And as you can see, it's built around the idea of apps. So we have different icons here that stand for different apps. One app that we have is the Sensors app, which basically shows you all the sensors that are connected to your system together with the actual measurements. So we have a movement sensor here. We have a dial here that we can turn, and which will be reflected here in the user interface. We also have support for GPS. So if we would have some GPS reception in here, you could see the actual position of the device here. We have, that's very nice, some bundle management. So basically in Machina.io, every software that I deploy is a bundle. Those of you familiar with OSGI know what a bundle is. For others, a bundle is basically some kind of zip file that contains executable code and metadata and every other data that you need. And what I'm going to do here is click on the install button. Then we have this nice drop field here. And I'm just going to turn off full screen mode and drop this bundle here from my, drop this bundle from the desktop on the field, and the new bundle is installed. Click on Start, and when we go back to the Start page, we see there is a new application icon here called the Real-Time Gauge, and click on it. And this is a nice little demo that uses WebSocket. So you can send data from the sensor basically directly to the web browser. So as I turn the dial here, you can see the display being updated in real time. And now we have some real cool thing built in, which is called the Playground. And the Playground actually is a complete JavaScript editor that's built into the web interface of Machina.io. So you can just open the Playground, type in some JavaScript, click on Run, and this JavaScript will actually run on your device. And this is pretty cool for trying out some stuff. For example, Here we have a little sample that will send an SMS message if the temperature exceeds a certain threshold value. And for sending the SMS message, we're using the Twilio cloud service. And here you can see some code that we have, which basically is talking to the Twilio service using the HTTP API. So we are creating a HTTP request here, fill in some data like account information, to whom to send the data to, and so on. Then we get the temperature sensor. In Machina.io, every sensor basically is visible in the system as a service. So you look for the temperature sensor service, get it, and then subscribe to the value change event of the temperature sensor. And if the value exceeds the temperature limit, we'll write out a warning message and send an SMS message. So I just click on run here and put my finger on the temperature sensor. And actually we could go to the sensors and devices page and see if you can get the temperature over 26 degrees, maybe. Okay, doesn't want to. Okay, anyway, if the temperature would exceed 26 degrees, we would get a SMS message to my phone. I also have some other samples that I can show you. Like, for example, sending data using MQTT. And just copy that out of the editor and go to the Machina.io page. And just drop in the new code. So here you can see basically again, first we're getting some sensor object, a temperature sensor and a humidity sensor. And then we are looking for the MQTT client in our service registry. Take the client, put together some JSON that the cloud service we are sending the data to requires, and just publish an MQTT message that will be sent to the cloud service. And can then go to the web interface of the cloud service. In this case, it's the AirVantage service. And we can see here the actual values. Okay. If you have any questions, I'm happy to answer them. Yeah. The first, repeat the question, how to get started with Machina.io. It's actually pretty easy. You go to Machina.io. There you can find, I just put it on the screen. You go to Machina.io. On this page, at the top, you find a link to the GitHub project. And then on the GitHub, you find some instructions for getting started. Basically, you clone the repository, you run make, and you're basically ready to go. So there's also some documentation on it. It will be extended over the coming weeks because it's still kind of a work in progress, but it's already nice to use. on the supported hardware side, you can run it on Raspberry Pi or basically any Linux device that you can find that typically some Cortex A8 stuff. On the sensor side, we currently support the Tinkerforge. We also support the Linux GPIOs that we have. We have coming soon some support for accelerometers built into Linux systems. We have support for GPS sensors that are connected over the serial port using the NMEA protocol. And we also soon have support for some kind of Zigbee sensors from DG. And you can also easily add your own sensors. It's basically taking some existing code and then modifying it to talk to your specific sensor. And then you can easily add new sensor types or device types. The Android sensors? Yeah, the question was, can you use mobile sensors already built into Android? Not at the moment, because you'd have to basically integrate them into the system, so basically write some interface code to them. Apart from that, Machina.io should also work on Android, so you should be able to compile it for an Android system. And yeah, some of the devices may probably work with the existing device supporter, but it kind of depends how, for example, the accelerometer is available in the Linux system. There are different methods for making the accelerometer data, for example, available in a Linux device like dev input or some other stuff, and it would depend on how this is implemented. There is a Java API to read the sensors, but as I said, this is all written in native C++ code, so probably have a bit of a hard time to integrate Java code into this. You could do it if you write a separate service that provides some kind of local API, so you can talk to it from Machina.io, but you cannot directly use Java in Machina.io.
There's time for one final last question.
Yeah, I guess the question basically was, what is the business model behind all of this? Basically, we have some additional features that we can license to companies, like better security. For example, you have the possibility to have signed code. You have additional support for some other features that you typically need as a professional user. We also do consulting services, also development integration services. Basically, we are offering all the services that a company would need in order to get started with this.
Okay, perfect. So, thanks a lot.